students, welcome you all to the video lecture on signals and system. Today we are going to see about the properties of Z transform. So we are going to see the three properties today: linearity, time shifting and time reversal. Okay, so first is linearity property. It is given by Z transform of A x1 of n plus B x2 of n equal to A x1 of Z plus B x2 of Z. So before proving the property, we should know that what is Z transform of x of n. So Z transform of x of n is given by summation n equal to minus infinite to infinite x of n z power minus n. Okay. So this term I can also write it as x of z. Okay. So in this, how we are writing here, x of n z power minus n. So here small x will become capital X and leave the power minus n. Whatever the base available, that you have to write in the functional value, which is nothing but z. So you should know this concept for proving the property. So Z transform of x of n is summation n equal to minus infinite to infinite x of n z power minus n, which is equal to x of z. How we are writing this? This small x will become capital X, leave the power minus n, whatever the base available, that you have to write in the functional value, which is nothing but z. Okay. So like that we have to analyze the formula so that it will be easy for us to prove the property. So take your left hand side. Z transform of A x1 of n plus B x2 of n is given by. So here again, Z transform of x of n is whatever you have here, you have to write as it is and then into z power minus n. Similarly here, whatever the functional value available, we have to write as it is. So summation n equal to minus infinite to infinite. Instead of your x of n, I have this whole term, write as it is. A x1 of n plus B x2 of n. Okay. So here x of n into z power minus n. Similarly, this is our x of n now. So that value into z power minus n. So now simplify the term. That is, we are going to split your terms. Okay. So summation is common to both the terms. Similarly, z power minus n is common for both the terms. So split your terms. Summation n equal to minus infinite to infinite a x1 of n into z power minus n. Similarly, summation is common for your second term also. Summation n equal to minus infinite to infinite b x2 of n z power minus n. Here a is constant, take outside. Summation n equal to minus infinite to infinite x1 of n z power minus n. Take b constant, which is outside. Summation n equal to minus infinite to infinite x2 of n z power minus n. Now compare this term. X of n, we are writing it as capital X. Okay, and then leave minus n, power minus n, the z we have to write. Similarly here a, instead of here x of n, I have here x1. So write it as capital X1. Okay, similarly here also z power minus n is there. Leave minus n, whatever the base available you write here. So a x1 of z plus b. Small x2 will become now capital X2. Here z power minus n, leave minus n. Here z I have, that you have to write in a functional value, which is nothing but a x1 of z plus b x2 of z, which is nothing but your right hand side. Okay. So hence the property has been proved. Okay. So next we will move on to the next property, time shifting property, which is, so take your left hand side. Left hand side is Z transform of x of n minus m. Okay. So now again we have to compare the general formula. Here Z transform of x of n is summation n equal to minus infinite to infinite x of n z power minus n. So summation n equal to minus infinite to infinite we have to write. Instead of your x of n, I have x of n minus m. Write as it is into z power minus n. Okay. So now again, inside the functional value, I should have only one variable. Okay, only then I can apply your term like this, x of n as capital X. Okay. So inside the functional value of x, small x, I should have only one variable, which should be a positive one. So whatever you have here, just replace it as one variable. Okay. So let me consider n minus m as another variable p. Okay. So what happened? n minus m is equal to p. Okay, so n is nothing but p plus m. Wherever I have n, I should write it as p plus m. Okay, so again, when n tends to minus infinite, okay, so it becomes what? Minus infinite minus m. P also tends to minus infinite. When n tends to infinite, suppose if it is infinite, okay, infinite minus m is what? Infinite. So p also tends to infinite. So there is no change in your limits. So when n tends to minus infinite, p also tends to minus infinite. When n tends to infinite, p also tends to infinite. So n is now changed to p. X of what is n minus m? N minus m is nothing but p. Okay, z power. Okay, minus what is again n? N is nothing but p plus m, which I have determined here, that you are substituting here. So summation p equal to minus infinite to infinite x of p. Split your terms, z power minus p, z power minus m. So minus p, minus into plus will become minus. So z power minus p, z power minus m. So here the summation is with respect to p. So here m value is constant. Okay, so that you can take outside. Z power minus m summation p equal to minus infinite to infinite x of p z power minus p. Okay, so now you compare this term. Okay, so it is similar to this formula, summation n equal to minus infinite to infinite x of n z power minus n. Similarly here, instead of n I have p, only that is only the difference. Okay, so this term I have tried as it is, z power minus m as it is. This is looking like this term. So small x will become capital X. Okay, leave minus p instead of leaving minus n, now we have to leave minus p. So whatever the base available, that we have to write in the functional value x of z. So small x will become capital X, leave minus p. The base available you write in the functional value. So z power minus m x of z. Okay. So this is the proof. Okay. So similarly you can try for x of n plus m. Okay. So definitely you will get z power m x of z. Okay. You do by yourself and check whether you are getting this. So there what you have to do, n plus m. Okay. So I'll give the hint, there you have to take n plus m equal to p. Okay. So n will become p minus m. Okay. So there is no change in your limits. So only this term you have to write. So it will become, instead of minus m, now it will become plus m when you substitute. Okay. Other than that, all the steps are same. So you will get this proof. Okay. So next is your time reversal property. So again, before solving the proof, we should know that what z transform of x of n is summation n equal to minus infinite to infinite x of n z power minus n, which I can write it as capital X of z. So take your left hand side, z transform of x of minus n is given. Okay, so this is reversal property. X of minus n is given, summation n equal to minus infinite to infinite. Instead of your x of n, I have x of minus n. Write as it is, x of minus n into z power minus n. Okay. So here again, as I said before, here only one variable should be there, functional value, and it should be a positive one. So let us consider minus n equal to some other variable p. So now n becomes minus p. Okay. So what happens to the limits? When n tends to minus infinite, p tends to, when n tends to minus infinite, minus of minus infinite becomes plus infinite, p tends to plus infinite. When n tends to infinite, p tends to minus infinite. Okay. So now summation will become p equal to infinite to minus infinite. Instead of writing minus infinite to infinite, why? Because when I substitute n equal to minus infinite, p becomes plus infinite. When I substitute infinite, it becomes minus infinite. So p becomes infinite to minus infinite. X of what is minus n? Minus n I know it is what? P. Okay, z power minus what is n? N is nothing but minus p. Okay, so I have considered minus n equal to p. So n becomes minus p. Wherever I have n, I should replace it as minus p. Okay. So here I have done like this. Anyway, generally in the limits in the summation, we will write a lower value down, higher value upwards. Okay, so lower value as a lower limit, so minus infinity to infinite. So this change will not affect your values inside. Okay, only in integration, when we change the limits, we will introduce minus, but here summation, it will not affect your values. So just change your limits. Okay, so now how it is looking like? X of p, okay, z power of, actually it is minus of minus p. This I can write as minus 1 the whole power minus p. Shall I write? It will not affect your term, correct? So z power of minus p is nothing but minus 1 into minus p. Minus into minus will become plus, correct? So actually it is plus p. Okay, so there is no change in that. I am writing it as minus 1 into minus p. Okay, so now compare your formula. So small x will become capital X. Similarly, small x will become capital X. Leave minus n. The base is what? Z. Here also leave minus p. The base is what? Z inverse. That you have to write in the functional value. Okay. So here we are leaving minus n, the power value. The base is what? Z, that we are writing in the functional value. Similarly, leave minus p here. What is the base available? Z inverse. So x of Z inverse. Okay, this is nothing but your right hand side. Okay, so hence the property has been proved. And one more thing, so this is your linearity property which follows your superposition principle. And next is see the term. Okay, don't memorize the property, see the term. The n has been shifted by some value, it has been subtracted by some value. N is what? Time. Time has been shifted by some value, either minus m or plus m. So this property is called time shifting. Next, time reversal. The n value has been changed to minus n. Okay, the reversal of your time has been done here. Hence it is called time shifting, sorry, time reversal property. Okay, so since I have x of minus n, it is called time reversal property. Okay, thank you. Thanks for watching.